Okay, now we'll do one numerical based on the Satp's law. At what temperature will the volume of a gas at 0 degree Celsius becomes double if pressure remain constant. Pressure remain constant means you can apply your Satp's law because volume and temperature is given. If you want to do it, as you know, V1 by T1 is equal V2 by T2. Here initial volume is not given, so you consider it as V. Suppose initially the volume is V and initially the temperature is 0 degree Celsius, but capital T represents always Kelvin temperature. So if the temperature is given in degree Celsius, you have to convert in Kelvin. So 0 degree Celsius means 273 Kelvin. So V2, second volume, you have to make it double. You have to make it twice V. If initial is V, then the final volume will be twice V. And you have to find out the second temperature. At what temperature the volume will be double. So if you put these values in the equation, V1 means V, T1 is 273, V2 means twice V, T2 you have to find out. That means your VV will be cancelled, twice V into 273, this is equal V into T2. VV will be cancelled, so ultimately T2 will be 546 Kelvin. You can convert in degree Celsius also. If you want to convert in degree Celsius, it will become 273 degree Celsius. So these are the application of your Satp's law. By applying the Satp's law equation, you can do this type of numerical if the temperature and volume is given at constant pressure. The constant pressure should mention, otherwise Satp's law cannot be applied. Pressure your pressure must be constant one. So now we'll do another law. Which is called Gay-Lussac's law. This Gay-Lussac's law, this law gives the relationship between your temperature and pressure at constant volume. So if you want to write the statement according to this law, this is called Gay-Lussac's law. It is also called Amundsen's law. According to this law, at constant volume, comma, the pressure of a given amount of gas, is directly proportional to its temperature. That means symbolically you can write the pressure of the gas is directly proportional to its temperature at constant volume and number of moles. Definite amount of gas means number of moles. So when you remove the proportional sign, a constant will come. You can write kt, or if you do P by T, then you will get constant. I mean pressure by temperature always remain constant. So if you change the temperature from T to T1, pressure also changes from P to P1, but the value will remain same K. Similarly, if you change P1 to P2, T1 to T2, then it also remain same. That means you can write P1 by T1 is equal P2 by T2. So this is the relation given by your Hamilton's law or Gay-Lussac's law. So Gay-Lussac's law gives the relationship between the pressure and temperature. Boyle's law gives the relationship between volume and pressure. Searle's law gives the relationship between volume and temperature, and this Hamilton's law gives the relationship between pressure and temperature. Now another law, already you have got this law, which is called Avogrados law. Important one. What is Avogadros law? This law is also applicable for gas. According to this law, at constant temperature and pressure, equal volume of all gases contain equal number of molecules. This is according to your Avogadros law. What is the meaning of this? Suppose there are two containers like this, and these two containers contain two different gases. Suppose this one contains oxygen gas, this one contains nitrogen gas. The temperature and pressure remain same in both the container. If the volume of this gas is 1 liter, the volume of this gas is also 1 liter. I mean at constant temperature and pressure, if the volume is equal, then the number of molecules present inside the gas is also equal. I mean at this temperature pressure, if 1 liter oxygen contain 100 molecule, then 1 liter nitrogen also contain 100 molecule. I mean at constant temperature and pressure, if the volume of the gases are equal, then the number of molecules inside the container also will be same. Your gases may be different, one is oxygen, one is nitrogen, but the number of molecules when you count, you will get similar number of molecules or similar number of moles according to Avogadros law, and that you can represent like this: V proportional N at constant temperature and pressure. Achha, do you know STP? What is the full form of STP? STP means standard temperature and pressure. And at STP, the standard temperature always considered as 273 Kelvin, I mean 0 degree Celsius, and standard pressure is considered as 1 atmosphere. And when the temperature is 273 Kelvin, pressure is 1 atmosphere, then the volume of 1 mole gas, I mean molar volume, is always how much? 22.4 liter. I think you know it. This is called molar volume, I mean the volume of 1 mole gas at standard temperature and pressure. I mean if the temperature is 273 Kelvin, pressure is 1 atmosphere, then 1 mole of any gas always contain 22.4 liters. And remember one thing, if the temperature is 273 Kelvin, pressure is considered as 1 bar, not as 1 atmosphere. If the pressure is 1 bar, then the molar volume you will get little bit different depending on pressure. You will get 22.7 liter. So when the pressure is given in terms of bar, then molar volume will be 22.7, and if the pressure is given in terms of atmosphere, you write 22.4 liters. Another condition you will get which is called SATP. This is STP and that is SATP. What is SATP? SATP means standard ambient temperature and pressure. Standard ambient temperature and pressure. And in this case, in SATP, the temperature is considered 298.15 Kelvin, and the pressure is considered as 1 bar if it is SATP, and at that time the molar volume you will get 24.789 liter. So if the condition SATP given, then molar volume you have to use 24.789. If directly STP given, you can apply 22.4 liter. And if the pressure is given in bar, I mean if the pressure is given as 1 bar, then the molar volume you have to consider as 22.7 liter. Thank you.